Hi everyone. Good evening all. How are you? Am I audible? Everyone?
Good
Good
evening, ma'am.
evening, ma'am. Yes, ma'am.
Yeah, good evening. You can unmute your system and you can talk. So this is our first session, right? So we are going to start with the demo on VLSI design and how we are going to learn this 6 months course and how the course is going to be structured like various modules and protocols, what will be the timing for each session and how are the assignments are planned and how the mock interviews are planned, the revision sessions and regular live sessions, on which days the live sessions will be going to start. Okay, so all these things we are going to discuss today. Okay, so hope everyone comfortable there and you are able to hear my voice, right?
Yes, ma'am.
Okay, so how many of you are 2025 passed outs here and still who are studying BTech and who are completed studies and doing work and want to shift to VLSI industry? So I think everyone there here, right?
Yes, ma'am.
Ma'am.
Okay. Okay, fine. We can discuss briefly about yourself and myself in some other days, maybe in the next session. Okay, so quickly we will
Okay.
move into the VLSI demo. So what is mean by VLSI? What are the major fields are there in VLSI? Why do you choose the design verification? What is the outcome of this course? Okay, so after this course, what will be the job opportunities? How can we apply for the jobs? What are the projects we are going to learn? All the details you will be getting. Okay, so whatever the doubts you have, you just ask your doubts anytime. Okay, so these sessions are entirely doubt discussion sessions and also very interactive sessions. Okay, lab and theory both are going to cover in these sessions. Okay, just give me a minute. Okay, sorry. So today we are going to start with the introduction of VLSI because first of all you are stepping into some career oriented course, right? So after this course you need to get proper job in the industry. Okay, so before getting into the course you need to understand properly what you are learning and what would be the future from this course. Okay, so today you will be getting the clarity what actually we are going to learn in this 6 months duration, what is the outcome of this course and how it will be going to helpful for you in the future to crack a job and how the projects are going to be helpful to crack any interview in VLSI domain, to select any resume, to select the resume in any of the company. Okay, so first of all these are the major things you need to learn to get into the VLSI domain. Okay, what is mean by VLSI? Today, just let me explain what is mean by VLSI. Importance of VLSI. I think you may already know about what is mean by VLSI, but still, whoever don't know, we need to discuss from basic scratch onwards, right? Still, if you know, just you can have ask some doubts and all. Okay, this session's totally doubt discussions sessions, right? More interactive sessions. Okay, if you are more interactive, most of the doubts are going to be clarified from here itself. You don't need to search again in the Google, you don't need to refer for the books and all. Direct to the trainer is going to discuss your doubts, and we will clarify your doubts here itself. Okay, so today we are going to discuss about the VLSI evolution, the history and future of the VLSI, and how it is impact in coming generations, and VLSI design flow, the career opportunity, what is the difference between different chips in VLSI, because final goal of VLSI is to manufacture a chip, right? So what are the different types of chips are there in VLSI, and how it will be helpful, and what are the advantages, disadvantages of each chip? Those are the things we are going to learn from today and Wednesday. Okay, your sessions will be alternate days, right? One day is live session, one day is assignment practice. So today live session means next day is assignment practice. Again Wednesday live session, Thursday will be assignment practice, so that you will get the time to learn very detailedly, because you are working professionals. Here there are working professionals and who are learning, who are studying a B.Tech, and who are doing M.Tech. There are different categories. So you need to get the time to practice, right? That's why we just kept the alternate days, so that you will get the clear understanding over the session, and also you are going to practice every day regularly. Whatever we learn today, immediately you need to complete the assignment without any pending work, so that you will be on with the flow, whatever we are discussing, and you will get time to practice. Okay, practice is important than teaching. We will teach everything clearly, whatever it required, but whenever you do practice, then it will be remembered for lifetime. At least it will, you can remember the concept till your interview. Okay, if we discuss some one or two problems in the session, means we will give you assignment to do 10 problems. Okay, so whenever you do 10 number of different problems, then you can remember that concept for long time. Okay, suppose today we start the digital logic design, means this digital logic design you can't revise every month. You will revise after 6 months whenever we are going for the interview, but this digital concept should be remembered till 6 months. Every month we cannot go back, and we cannot read old topics, right? Every month we are upgrading ourselves. First digital logic design, then Verilog, then SystemVerilog, then UVM, then projects, protocols. So I am suggesting you to everyone, whatever you are learning from the day one, try to learn very in depth. We will teach you every concept in depth. Okay, not just a basic. Even digital electronics, we will give you a lot of problems. We will teach you a lot of problem statements, how to write the logical some logic to any of the problem statement in combinational, sequential, registers, counters, FSM, memories. Everything will be discussed in terms of problem statement and problem solving. Even in Verilog, we do lot of codes. Okay, one code in 10 number of styles we are going to do. So then only you can able to remember properly. I know you will forget every concept after 1 or 2 days. Okay, but if you read just 50%, even you don't remember for 1 day. If you practice more number of problems, then at least you can remember for a week or for a month. The final thing is you don't remember anything after 1 or 2 weeks. Okay, but whenever we are practicing more problems, at least you can remember that concept for at least 1 month. Okay, so that is what I want to tell for everyone. From day 1 onwards, put a timetable from today. Okay, don't miss the any session, don't miss the flow. Even if you miss the session, you will get the recorded sessions. Okay, you can revise the sessions next day, but don't miss the flow for 1 week, 10 days. 1 or 2 sessions means okay, you can revise easily. But if you miss 1 week, 10 days means the new concept will start in future. in next coming days. So you will miss the previous sessions. So that will be very clumsy if you don't put proper time. Okay. So from day one onwards, everyone put some timetable for this 6 months very strictly. Why? Because these are career oriented. These are not like your academics. If it is like academics, we can study next week, after a month, even before semester exam, one day before also we can learn and we can write easily. Okay, but these are job oriented. Whatever you are learning from day one onwards, these are very important till you get your job. Not only till you get your job, after getting job also, these are very important concepts. Okay, so whenever you have strong knowledge from day one onwards, then it is easy to crack the job whenever more. Because see one thing, nowadays industry expectations are very high from a fresher. First of all, there are no much openings for freshers. Okay, suppose if there are 100 people, we think 15 people only have the opportunities. Okay, in that 15, we need to get the placement. We need to be at least in top 10 position. Provilogic students should be at least top 10 position. Okay, out of 100. So that is what our main goal. That is how we are giving the training for the students in online and offline. Offline is very good because from morning to evening we will be in the offline. The students will be in offline. They will do labs, theory sessions. Even they are doing very good projects in Verilog at learning stage only. Last in June batch has started, right? Just Verilog sessions, very few 6 to 7 sessions are completed. On day of sixth day only, they did some project. We got some MTech related project, low power analysis, linear feedback, shift register project we got. I just given the project to them just to do. But they did very seriously. They did like these people are very active in the session. Okay, pro really. Okay, so they did very easily the project because till before 6 days, whatever the Verilog sessions completed, we did totally practical sessions. Okay, in that 6 days, from basic Verilog to what are the rules we need to follow, how to write the program in different styles like behavioral modeling, data flow modeling, gate level modeling, switch level modeling, structural modeling. Not only the manual type of coding, how we can write the 30 lines of code in single line. These type of logics we did lot. So from that experience, they did the project. They won. Just there are group of people, girls and boys. They just sit and they did the complete project in just one day. Not even one day. I given on from afternoon after lunch. I have given the project. By end of that, till 7 o'clock they are in the office. They did the project. Till 1 o'clock they went to the mentor room and they did the project. Actually, we don't allow them to go to mentor room and all, but boys went to the mentor room and they did the project with mentor support. So that is what enthusiasm, that is what dedication we are expecting from the students, so that we can help them more with the projects to get more hands-on project, because our final goal is to get the job, right? So to get a job, we need very perfect skills, very good technical skills, not just theory skills. We need the project oriented skills. If any problem statement is given, how we can solve that project, that is very important. Day one onwards, we need to think in that point of view only. So how we can apply this concept to do some project, to do some practical application. Okay, so everyone remember this point. So whoever enrolled for this course, just make the schedule perfectly for these 6 months. From our side, we will be very perfect according to the curriculum, according to the knowledge, according to the assignments, everything. We will be perfect from our side. From your side also, everyone today take just a book. Everyone maintain a book. Okay, this is first session, right? I am telling everything clearly because this is very important course for you. It's a life turning course, right? If you get the good job, you will be in a great position in the industry. If you don't get good job, you will be in somewhat position in the industry. If you don't get job, you will be need to check for years of years. You need to apply for the jobs and try for the jobs. Okay, so our goal is to get a high position job, okay, in the industry. So to get the job from day one onwards, we need to sit properly. We need to do all the concepts, whatever in the curriculum we have mentioned. Okay, just follow the mentor guidance, and whatever the assignments are given, just follow the assignments, and whatever the doubts you have, you just ask your doubts. You can get with the good ideas. Okay, and just work on different problem statements. Whatever we are discussing here, anyway we will give you a lot of problem statements, lot of assignments, but from your side also come up with a good problem statement, some projects. So we will do a lot of things. If possible, you can come to the offline weekly 1 or 2 times, or monthly 1 or 2 times, or at least for projects you can come to the offline at least for projects, or in the weekends you can come, you just visit. Okay, or else if you don't have time, you just practice from your home. But practice is very important. Okay, through practice only you can remember the concept perfectly. Okay, everyone got my point?
Yes, ma'am.
Any
Yes, ma'am.
doubts?
No, ma'am.
Okay, fine. So this is what today and Wednesday session will be the demo sessions. Okay, so we will discuss what is the schedule first. What is our course curriculum? We will discuss first. Okay, we have two type of courses. One is a
Sorry.
professional. Hello.
Can I have a question?
Yes, yes.
Is this the more cost of professional growth for ASIC design verification?
Yes, yes.
I
Actually,
got it.
yeah, please tell. Hello.
You can continue. Thank
Okay.
you.
Okay, thank you. So what is our curriculum? Our course curriculum means, first of all, we have freshers course and a professional growth course, right? For 2025 passed outs, we suggest the freshers course. Below 25 passed out, that means 24 or 23 or 21, 22, even 20, below 20, we will suggest the professional growth course. Why? Because freshers course means they are going to learn first 6 modules.
Hello.
Hello. Yeah, am I audible now?
Yes, yes, yes.
Yes, ma'am.
Yes.
Okay. Just a power connection, disconnection. Okay, fine. Okay. So for freshers, we will suggest the freshers course. We have professional and freshers course. Freshers module 6. They more advanced level of system. Advanced level is here.
Why my voice is breaking? Your voice is not clear.
Power is gone. Am I audible now? Is it clear now?
Yes.
Okay. Fine. Fine. Okay. So first of all, we have two type of courses: freshers course and professional. Passed out, and if you are running from IT to VL abroad, you need much more knowledge. The gap, 2 years of gap, 3 years. Okay, just a second. Please. For important meetings only, we will lose the current. Okay, am I audible now?
Yes.
Is it audible now, guys?
Yes, ma'am.
Okay, fine. Okay, fine. So, for professional growth, if you're late passed outs, or if you're shifting from IT to VLSI, and if you're looking for career change, if you're doing masters from abroad, you need much more knowledge comparatively freshers to fill that gap, from late passed out to till 2025. If 2 years gap is there or 3 years gap is there, we can fill that gap with the best industrial level projects. Even freshers also get the projects and protocols. Total 5 industry protocols we are covering, 3 major projects we are covering for freshers. But for experience, whoever have the gap, we have best protocols and projects which are more advanced level, like PCIe, DDR5, SOC level verification and debugging projects. So these are very good client-based projects. So professional growth course is suggested for below 25 passed outs. Okay. So based on that, first course module. First, we will start with the introduction to the VLSI design. Introduction means, first of all, you need to know what is meant by VLSI, what is meant by front-end domain, back-end domain, industry requirements, FPGA, ASIC chips, SOC chips, what is meant by nanometer technology, and what is the future technology. If you observe last 1 week in newspapers and news, everywhere we are listening that the quantum computing, quantum valley, the Amravati is going to be soon going to be as a quantum valley. So that is the most advanced technology is going to come next in next 2 to 3 years. So we are going to discuss on that, what is meant by quantum computing, how the industry is going to be changed in next 20 to 30 years. Okay. And then we are going to start with the digital electronics. Mostly from Friday onwards, we are going to start with the digital logic design this week. Okay. First 2 sessions will be the introduction sessions. So from Friday onwards, we are going to start with the digital logic design. In the digital logic design, what we are going to learn means, in the digital logic design, first of all, we will start with the basic concepts to the advanced concepts. See, digital logic design you already learned from your academics. So whatever you learned in academics, that is not much useful, right? We need to learn everything in a problem solving. If any logic is given to you, how you can solve that problem, how you can apply the logical skills to solve the problem, what are the steps we need to follow to solve any logic. So those things are mostly interview point of view, interview questions, because if you go for a job opportunity, first thing as a fresher, you need to write the entrance test. In entrance test, most of the questions will come from the digital logic design, Verilog HDL, C language, aptitude and reasoning. Okay. So for that purpose, mostly The interview questions will be the problem solving questions in digital logic design in every concept from Boolean algebra, K-maps, logic gates. Like if any gate is given, how many different ways you can design a gate, how many different type of multiplexers you can design using the gates. So like that, there are a lot of logical questions. So we are going to design all those things in just 3 weeks. Within 3 to 4 weeks, maximum 3 weeks, we need to complete the digital logic design. We don't need to spend more months of time for digital logic design, because you already know the concept. We need to learn more into the logical implementation wise. Okay, so combinational, sequential. First 1 week will be the total basic concepts, like what is meant by two's complement, how can we convert the positive value to negative value, Boolean algebra, logic gates, expressions, K-maps, De Morgan theorems. Everything will be the practical sessions, assignments. First 1 week. Second 1 week will be the combinational logic circuits and sequential logic circuits, latches, flip-flops. Third week will be the registers, counters, FSM, final state missions. Okay, memories will be discussed in the Verilog. So like that, in additional to that, we are going to cover the glitches, hazards concept, CMOS concepts, static timing analysis concepts also going to be covered in digital logic design. Okay, next will be the RTL design. After this 3 to 4 weeks of digital logic design practice, we are going to start with the RTL design. In RTL design also, there will be regular live sessions like lab and theory sessions combinedly. Okay, so in that case only you can learn everything practically. We don't have separate lab sessions, separate theory sessions. Everything is combined. So every logic you will write in a practical. Okay, so first we will start with the data types, operators, how many ways we can write the program, like behavioral modeling, data flow, gate level, switch level, structural modeling, and how logically we can write. Because if you see in industry, whatever we are using here, behavioral modeling, data flow modeling, gate level, those will be not much preferred. Just a second. Design. Hello, am I audible?
Yes.
Yes,
Okay. Okay, if you see here in digital logic design, suppose there is a system on chip design. Our final goal is to design a system on chip, which is a current trend in every mobile phone, every laptop. The structure we call as a system on chip design. In the next session, I will give you the clarity what is meant by ASIC, FPGA system on chip design. What are the different components will be available in the system on chip design, like a processor, graphic processor, memory controllers, interconnect, IO peripherals. Like that, there will be lot of blocks in a system which we interconnect. If you see olden days motherboards, you know the computer CPU, right? In CPU, if you observe properly, there will be a motherboard. Every CPU have some PCB board. Upon a PCB board, there will be a motherboard like this. In motherboard, if you see what are the different components are available here, there is a processor which we call as a central processing unit. Okay, and there will be some graphic processor. If it is required, then only we can integrate the graphic processor. Mostly in olden days, the Photoshopy people or video graphic, whoever doing the video graphic related or gaming related, those people only use the graphic processor, which are more helpful for the to generate high pixel quality in a video purpose, in a video gaming purpose or Photoshopy purpose. Okay, so then only we will integrate the graphic cards. So normal CPU graphic cards are not required for normal people like you. If you are doing the coding or if you are running the small applications, for that people graphic cards are not required. And if you see these long slots, these slots are PCIe related slots and memory related slots, RAM, ROM. and there is a lot of circuitry here. North bridge IO, south bridge IO, left side if you see HDMI cables will be there, USB cables are there. Even in the laptop, whatever the current laptops you are using, we will have the USB cable left side or right side. There will be some HDMI cable, and the mic in the sense earphones. We use the earphones, right? A small round cable will be there, like the charging port will be there. So there will be lot of ports side. Okay, so this is a olden days architecture, which we call the ASIC chips in the motherboard. Okay, there will be a PCB board. On the PCB board, we will connect a lot of components. That's what we call as a motherboard now. But now the trend is changed. Whatever the laptops we are using, whatever the mobile phones we are using, everything is a system on chip design. System on chip design means if you see right side, there is a chip, integrated chip. On the chip, there are several functional blocks. There will be a processor, integrated processor will be there, integrated graphic processor will be there, memories are there, the interconnects are there. So this is what actually we have in our architecture, in system on chip design architecture. Okay, I will explain you very clearly in the next session, this entire architecture, what will be there exactly inside. Okay, so if you see here in this architecture, whatever the IPs subsystems you are seeing, there will be lot of digital blocks involved in this. Okay, so it have the combination of full adders, multiplexers, arithmetic logic units, and encoders, decoders, and finite state machines, registers, counters, memories. Lot of circuitry will be involved in a IP block or system on chip block. Okay, so whenever lakhs of digital blocks are involving in some circuitry, how we need to program the digital circuit? Very simple. Suppose 100 number of multiplexers you are using in some block, if you think, okay, 100 multiplexer. So each multiplexer, if you write a program in 30 lines, in 60 lines, 120 lines, then how many number of lines you need to write for 30 number of multiplexers? Just think once. Suppose if you see, multiplexer means it have 2 power n number of inputs, and there will be n number of selection lines, and there will be a single output. So whenever number of inputs are increasing, obviously the complement of the complexity of multiplexer will be increased, right? 2 power n, that means 2 power 3, 2 power 4, 2 power 5, 2 power 6. So when it is coming to 32 number of inputs, 64 number of inputs, if you write in a if else loop, if else or case, using case or if else, nearly 60 lines, 120 number of lines of code we will get. Okay, so is it good way of coding the 120 of lines for single multiplexer? Like that we need to write 100 multiplexer. That means each multiplexer having 120 number of lines. Is it good practice to write the program in industry level? Hello. Yeah, am I audible? Okay, so it is not good practice to write a simple code in hundreds of lines, right? So every time we need to understand how easily we can write single line program for multiplexer, single line program for demultiplexer, encoder, decoder, shift registers, counters. How can we write a simple counter logic, not like in a structural modeling? So all these things we are going to learn in a Verilog HDL. Okay, so this is what the curriculum for Verilog. We are going to design every block, every digital circuit in Verilog, from combinational to sequential to FSM, memories, FIFO memory, RAM, ROM, all this. Okay. And next, after Verilog HDL, SystemVerilog. SystemVerilog also same. Both the theory and lab sessions will be discussed in the same session. Okay, we will start with a very basic ABC. Even if you are a fresher, you can easily learn like ABC of SystemVerilog, like data types, operators, test bench architecture. Test bench architecture is very important in SystemVerilog. Okay, so if I will tell you one point here. Why we are moving for the verification to SystemVerilog, from Verilog to SystemVerilog? You may get the doubt, why don't we do the verification using Verilog HDL? Because we are able to write the test benches in Verilog HDL also, right? But why we are moving to the SystemVerilog means, if you see, if it is a small program, if it is just a multiplexer or if it is just a shift register, or if it is an encoder or decoder, or even small application like a LCD display, display, 7-segment display, or a small digital alarm or digital clock or traffic light, for small applications we can use the Verilog, but still it takes a lot of time. We don't we don't get the 100% test coverage in Verilog. But why we are using SystemVerilog means, if you see here, the complex system on chip designs which we are using in the industry, this is what actually we use in the industry. You will heard like Ryzen processors. There will be iOS for Apple. They have their own processors. ARM related processors, or their Snapdragon related processors will be there for Qualcomm. So every company have its own chips, have its own processors, okay, have its own system on chip designs. Okay, so in a system on chip design, there will be thousands of digital blocks, whatever I told now, 7-segment display, digital alarm, digital clock, and the traffic light controller. Like this, there will be thousands of blocks in one circuit, one chip. Okay, so it is not so easy to communicate all thousands of blocks. It is not so easy to verify all hundreds of blocks by using Verilog HDL. It takes years to verify using the Verilog HDL. That's why SystemVerilog is a more advanced language, which is a dynamic environment where we use the real-time scenarios by using the object-oriented programming. And also there are a lot of best features where we get the 100% functional coverage through the SystemVerilog and UVM. So if you want to verify these type of complex designs which we are using in our laptops, mobile phones, any digital gadget like a watch, ATM machine, or lift controller, vending machine, any block if you consider, it have lot of complex designs. To verify those type of complex designs, it is not very easy to do with the Verilog. That's why we are moving to the SystemVerilog for better verification. Okay, so did you got the point, everyone? Why we are moving to the SystemVerilog to get to get 100% coverage and 100% verification?
Yes, ma'am.
Okay. So that is what the importance of SystemVerilog. In SystemVerilog, we are going to learn every concept: test bench architecture, arrays, what are the different type of arrays, or the limitation of Verilog, advantages of SystemVerilog, task, functions, interface, virtual interface, which is a very good concept where the Verilog have lot of limitations compared to the SystemVerilog due to the virtual interface concept. Okay. So what is meant by clocking block, mod port, and most important thing is object-oriented programming. I think you may heard in Java or Python language, C++ language, what is about the object-oriented programming. Object-oriented programming means where we can connect everything in real time by using the classes and the objects. Okay, so simple example I will tell you. Suppose by using a Verilog HDL, we are doing the randomization. Okay, randomization means assigning some random values. Directly we use the $random, we just assign the random values. Okay, so A is equal to some random value, like that 100 variables are there. 100 variables, we are doing the randomization and just assigning the random value. So in Verilog HDL, If you want to do the randomization for 100 variables, you need to write 100 times A is equal to $random, B equal to $random, C equal to $random, D equal to $random, address equal to $random, data equal to $random, reset equal to $random, clock equal to $random, enable equal to $random. Like that, every variable you need to write $random, like that. But in SystemVerilog, by using this object-oriented programming, by using this object concept, just by creating the class and object of that particular class, we can use dot randomization, only single method, dot randomize. By using the dot randomize, all 100 variables will going to be randomized, just a single variable. That is the beauty of SystemVerilog. Okay, not only randomization, you can control the randomization also. Controllability means here in SystemVerilog we have a concept called constraints. Constraints means suppose address is a 32-bit. 32-bit means we need to generate 2 power 32 number of scenarios we need to generate. You can think 2 power 32 number of scenarios means how many scenarios you will get. But sometimes we may not require 2 power 32 number of values to do some verification. Okay, we may require only some scenarios, 0 to 100 number of scenarios, or 100 to 200 scenarios. Within that scenarios also you may require only even number of values, or you just need odd number of values. Okay, so particularly whatever the required values you need, that required values you can generate by using the SystemVerilog concept, which is not available in the Verilog concept. Okay, so like that, there are lot of advantages with the SystemVerilog, even coverage, assertions, arrays. Okay, so these all things we are going to learn practically by writing the coding. You can observe everything like polymorphism, encapsulation, virtual interface, the abstract class, inheritance class, everything we are going to learn through practical sessions. Okay, so next, coverage analysis. In coverage, we have different type of coverage like a code coverage, functional coverage, toggle coverage, cross coverage. There are different and assertion based verification is one of the important. After that, main important concept, as a verification engineer, you are the future verification engineers, right? So if you want to become a good verification engineer, first of all, you must have proper knowledge of developing the test benches. Okay, so in this SystemVerilog, we are going to develop nearly 5 to 6 test benches in design, verification, and also in projects. Okay, nearly 5 to 6. If you properly concentrate on these test cases, test benches, you will become a very good verification engineer if you properly concentrate. Okay, so whatever the concepts we have discussed till now, arrays or OOPS concept or coverage, randomization, constraint, by using all these concepts, finally we are going to develop the test benches. Okay, so that is what all the concepts here, and there will be regular assignments, a mock interview every weekend. There will be a mock interviews personally, one-to-one. From this batch, we are going to assign some more mentors, personally guidance, to give the personal guidance mentors. So they will directly talk with you every week, and every Sunday there will be the revision session for you. Okay, so total interview preparation will be there. Next, coming to the module 4, most important module for your course curriculum, that is a UVM. UVM is the major course for the verification engineers. That too, we are going to learn very clearly for UVM. Okay, most of the freshers will confuse a lot with the UVM concepts. They don't understand properly what is what. But in our sessions, we are going to discuss very detailedly all limitations of SystemVerilog to advantages of UVM. What are the limitations we are facing with the SystemVerilog? What limitations we are facing with the UVM? Okay, UVM features, hierarchy. In SystemVerilog, however, we have test bench architecture. In UVM also, we will have the test bench architecture. So that's what we are going to discuss. Phases, driver, mount, everything. We are not going to skip any of the concept here. And also I didn't include it here. Actually in UVM we have lot of concepts like virtual sequences, virtual sequencers, the RAL model is there, configuration database is there, and for factory registration also not mentioned here, but these are the main concepts we are going to discuss. Factory registration, okay, we need to update the curriculum again. So finally we are going to design the detailed test plan for the UVM. Okay, next, Perl scripting language. Perl scripting language also you will be getting. This is not much required for freshers, but we already added the Perl scripting language. It's totally 1 to 2 weeks scripting language. You will be getting all, like, what is the importance of Perl scripting means. I will explain you briefly. Suppose if you see here, in a system on chip design or in a IP level design, okay, we write thousands of test cases. Normally, in learning stage, we will write only 1 or 2 test cases. So that 1 or 2 test cases, we can directly verify. We don't need any scripting language or we don't need any commands. But in real time, we run thousands of commands. We upload the coverage. We extract the coverage with thousands of test cases. That time, whenever you want to run at a time all the test cases, then the scripting is very, very, very important. It makes the task easy, because by using one command you can run 1000 test cases. At finally server, in server, you will get all the details. What is the name of the tester? What is the functionality of this tester? Whether the test is passing or whether the test is failing. If failing, what is the error of the tester? Entire table you will be getting. That is what the importance of scripting. Where you will learn the commands to design, to run all thousands of test cases. From SystemVerilog and UVM, you will be learning how to write the test cases. From Perl scripting, you will be learning how to run thousands of test cases. It has a lot of concepts. You need to learn from basic concepts. Okay, so we will explain everything. Okay, so coming to the module 6, projects, protocols. Actually, these projects and protocols we will start from SystemVerilog only in weekends. SystemVerilog sessions will be weekly 3 days, in weekdays. In weekend, Saturday, Sunday, after completion of half SystemVerilog, we will start projects and protocols. So parallelly, it will be covered. If you want to apply any internships from your side, if you are in final year, or if you are looking for internships, you can start apply. Okay, so projects and protocols will be started from SystemVerilog itself. First, we are going to start with the UART protocol, very basic protocol, and also very important for the resume purpose. Just a second. Okay, so first we are going to start with the UART protocol. Okay, we are going to explain entire specification, what is meant by protocol, what are the different protocols available in system on chip design. Actually, if you see here, this is what system on chip design. Okay, these orange colors are there, right? These orange colors are nothing but interconnections between the processor to memory and processor to these IO peripherals, wireless subsystem. I will explain you in the next session. You will get more clarity. Okay. See, simply here, suppose human brain is there. Okay. You already know processor will work like a brain. However, the human brain is working. It just generate the multiple instructions and send to entire body through the neurons, whatever the nephrons, the wire, the connections are there, not wire connections, the neural connections, whatever the nervous system is there in human body, to communicate from brain to till entire parts of the body. Same here in system on chip design. Whatever the processor is there, the processor is going to generate multiple instructions. Based on that instructions, the entire system is going to work. You already learned the assembly language programming in your BTech level, right? How to design a processor by using assembly language program like instruction set architecture, x86, the Intel x86 or 8085, 8004 microprocessor. Now in our course, we are going to learn the RISC-V processor. Okay. So, however, the processor is going to make the communication between entire system on chip design here through this orange color bus. These orange color are nothing but the protocols where we transfer the data between different components in the system on chip design. However, the nervous system is communicating from our brain to all the parts of the body. Same here, these orange color bus protocols, serial communication protocols will be there. That's what we are going to learn in these projects and protocols. Total 5 industry protocols we are going to learn. First one is a UART protocol. UART protocol is how the data is transferring from our laptop to the external device. If you connect the mobile phone or if you connect the printer, scanner, USB port, you already know, right? USB port is a current trend. The senior experienced engineers will learn. But at fresher level, we need to learn the UART protocol. So you are going to learn total RTL design and verification of UART protocol. I2C protocol. This is within the chip. Every protocol have its own specification. Okay, we are going to learn I2C protocol, entire design, Verilog design using RTL. I2C is going to verify in SystemVerilog. SystemVerilog 2 protocols, UVM 2 protocols. Okay, I2C and APB in SystemVerilog, AHB and AXI in UVM. Okay. And finally, 3 major projects we are going to do. Okay, 3 major projects will be maximum RISC processor, DDR memory, or router project, 4-port calculator project. I will give you a list of 6 to 7 projects. You can select any 3 projects because my intention is everyone should not have same projects in the resume. Okay. From Provilogic, if you are sending 15 resumes to the company means for placements, every resume should not have same projects. They should have different projects. That's what my intention. So that's why I will give you total 6 to 7 projects. You can select any 3 projects according to your interest. Okay. Next. Coming to the professionals, till here freshers course. Okay, coming to the professional course, there will be extra 1 month for SystemVerilog and UVM lab sessions. Totally how we can analyze the coverage for different test bench architectures, for different protocols, problem statement, assertion based verification, deep into the development of test plan, test cases, the protocol verification, debugging techniques, regressions, everything will be in like most advanced level where you can able to answer for an interview. If you put some 3-year experience gap, if you have 3 years or 2 years experience gap, for that people it will be mostly useful. Okay, so that is what module 7 for professionals purpose. And SOC design. Module 8 is for SOC design and verification. Here we are going to develop the SOC. We already developed the SOC with the basic processor, interconnection with the memory controller, and bus interconnection will be there. So this is what totally we are going to design and verify. This is actually client based project, client level project. Whatever we are doing in the client, that project we have involved here. Okay. So these are the total 8 modules we are going to learn in this particular course. Did you all understood, everyone?
Yeah, ma'am.
Okay. So In the next session, on Wednesday, we will discuss on what is mean by VLSI. I think you already got the things. What is mean by VLSI, Moore's law, VLSI design flow, like front end domain, what we are doing, like in front end domain. I will explain you all these things. What is the Moore law and what is mean by nanometer technology and what is mean by CMOS, FinFET, GAFET, and how we are moving to the 0 nanometer technology and what is the future technology which we are talking from last 1 week. We are talking about the quantum valley in Amravati and quantum techniques, right? I will discuss everything clearly on the Wednesday session, and we will start with the VLSI design flow. What is front end? What will be there exactly? What is the role of design verification? What is the role of physical design and DFT, logic synthesis team, total ASIC design flow? What is the difference between ASIC, FPGA, and system on chip design? What is the roadmap? Okay, we will discuss everything in the Wednesday session. Everyone, please try to join. Whoever joined today, I will share you the link, same link. You can join with the same link. I won't be sharing any link again. It will be again some. Today I have shared to a lot of people, right? I don't know who joined and who didn't join. Okay, please try to join on Wednesday also at 8 p.m. with the same link. Okay, so you will get the clarity on entire VLSI from Friday onwards. From Friday onwards, we are going to start with the digital logic design. Okay, I'm again telling you, whoever enrolled for the course, please try to maintain a book. You need to write everything in the book. In on offline means we will talk with the students everything detailedly, and if they didn't do properly, really I will scold them a lot. I will stand near them till they write the everything whatever we discussed, but it will be not possible in online. So you need to self study and you need to ask the doubts. You need to come up with the doubts, and please ask your doubts here. We are going to explain you very clearly. Please maintain a book, okay, and write the schedule regularly. And assignments, we will give you all the assignments and how to submit the assignments, and we will note down all your marks regularly. Okay, so be strict from day 1 onwards. Okay, actual course will be starting from the Wednesday, and from Friday onwards digital logic design. Okay, any other doubts remaining? So the course duration, every session will be 1.5 hour. We will discuss whether to start at 8 p.m. or 7:30 p.m. If you guys are comfortable at 7:30 p.m., we will start at 7:30 to 9:30, 2 hours session. Okay. Or if you comfortable at 8 o'clock, we will start at 8 o'clock. We will discuss that because it will be the dinner time, right? Most of the students have mess and all. So we will discuss that time and we can plan according to your availability. Okay, so whatever the doubts you have, you can ask your doubts regularly, and please maintain the timetable. Okay, any other doubts from remaining? Any doubts? Please try to attend the session on Wednesday also. These are alternate days. One day is live session, next day is for assignment practice. Whoever enroll, we will share you the assignment for today. Today assignment, the mock interview and assignment. Okay.
Ma'am, is there any reference link or any particular website that we should refer to during the course of this program?
Yeah, we have materials. We upload every codes in the GitLab, and we are going to share the access through Drive for assignments, materials, books, everything.
Okay. Okay.
Yeah. Okay. 6 to 7, we don't have the batch for 6 to 7. Okay. We can adjust this batch session timings based on the people availability. We can adjust to 7 p.m. or even 8 p.m. Okay. Mostly the session duration should be 1.5 hour to 2 hours. Okay. So in 1.5 hour to 2 hours, we will discuss everything properly. So you will get lot of information from that session itself. Next day total will be the assignment practice. Okay, guys, if you have any doubts, please you can contact me. I already shared the WhatsApp. We already connected in WhatsApp, right? So if you have any doubts, you can please contact there. And please try to join on Wednesday also. Okay.
Okay.
Okay. Okay, then thank you all.